Welcome back. Our final example problem again is very similar to what we've been doing. So if you feel confident about doing example A, I encourage you to do so. Otherwise, let's get started. So here's example A. I just wrote it at the very top of my graph like I did with all the rest of my functions. Okay, well let's start graphing this, you guys. So again, this function is impossible to do on your calculator. You cannot find most of the key features using your graphing calculator. So again, most of the time with square root functions, Desmos.com is going to be your friend. So I encourage you to try Desmos.com while graphing square root functions, because a lot of the times your graphing calculator won't be able to help you on a square root function. Alright, well let's get started. So we have y equals negative square root, so you can type SQRT, or you can hit the keyboard and hit the square root button. Alright, and then we have 3x minus 4. Oh. Good golly, the demon cats just keep getting me, you guys. I don't know what's going on. Alright, so 3x minus 4, again, to get outside of the square root, hit the right arrow key, and then minus 2. Okay. Alright, sorry, knocked over my microphone. Alright, well here's our lovely square root function. The key point on here is our start point. Remember, the start point tells us a lot of different key features about our graph. Now on this one, if you see, a lot of the other functions, it just let you click on the point. If you guys see here, this one's not letting you. You can kind of click above it and try to drag it to that point, but if you see, it's really hard to get to the start point. So I kind of warned you earlier, sometimes even Desmos won't let you find the point. You can approximate it, because I can get a point here. What you do is you click and hold down, and you can kind of drag the point as close to that start point as possible. So right now, if you see, I'm at about 1.3, negative 2. Okay? But again, if for some reason you're having a hard time getting that point, I'm going to show you another way to get that start point by just solving on your paper. So I'm going to show you how to get that start point a different way. Okay, so I kind of told you earlier, another way to get that minimum or maximum point, which is where we get from our start point, is to find the domain and range. Okay, which in this case, since I know it tells us right here what the point is, I know, but that's because Miss Long had to find it on her own, and then I just made a point on the graph. So we're going to ignore that, because when you guys do this on your own, you won't have that information on your graph. Okay, so currently, I don't even know what this point is. So I need to find this point in a different way. And the way we're going to find it is through the domain and range. Okay, which in this case, since I don't know the start point, okay, we're going to have to solve this one algebraically. I won't be able to use the graph because I don't know how far left it goes, because I don't know what this point is. Again, I kind of do, but I'm pretending for now I don't know. Okay, so I'm going to solve for the domain using the technique I taught you earlier. Alright, so the domain will be, you set everything underneath the square root to be greater than or equal to 0. So I'm going to set 3x minus 4 to be greater than or equal to 0. Okay, when I solve that, it will give me the x value of this point. The range will give me the y value of my start point. Okay, so I'm going to solve this real quickly. I'm going to add 4 on both sides, which negative 4 plus 4 cancels and turns to 0. 0 plus 4 is 4. So I'm left with 3x is greater than or equal to 4. Alright, and now to solve for x, the 3 and the x are secretly being multiplied together. So the way that I move 3 to the other side is by dividing that thing on both sides. 3 divided by 3 will cancel out, so I'm left with x is greater than or equal to 4/3, which as a decimal is 1.333. So I'll show you on your calculator real quickly. And again, it's approximately, I can't even remember how I got that point exactly, so I don't remember if I approximated it or not. Alright, so real quickly, if I do 4 over 3, enter. Alright, so you get the 1.333. So that's where that 1.333 came from. Again, I probably just typed that in my calculator and approximated it and was able to find that point. So again, you can get it pretty close, but unfortunately, even Desmos is kind of letting us down on this problem. Alright, so again, that's how you find that point. So that is the x value. So if you want to use a decimal, you could say x is greater than or equal to 1.333. Alright, so that is how you get the x coordinate of the start point. The way that you get your range is by identifying the k value if you think about transformations. So the k value is whatever is added or subtracted to the very end of the square root, which happens to be -2. And since my graph is heading downward, remember the shortcut, if it's decreasing, it's y is less than or equal to k, which happens to be y is less than or equal to -2. Or another way, these values are all lower than 2. They're less than 2. So that's another way to determine that it's less than or equal to 2. Okay, so that is how you get the y value of your start point. Okay, so this point came from the domain. This point came from the range, or this value in the point. So the x value came from the domain. The y value came from the range. So if your graphing calculator and or Desmos is failing you, another way to get your start point is by finding the domain and range. Okay? Alright, so let's get going, you guys. So on this one, we currently don't have any x-intercepts because the graph does not smack the x-axis. Okay, it doesn't touch it. Also, the graph never smacks the y-axis. It never touches the y-axis. Okay, so this graph does not have an x or a y-intercept, which is double sad, you guys. This problem is like really depressing. I couldn't find the start point on Desmos, and now we don't have an x and y-intercept. What's going on? Alright, so this one we don't have any, so none, and we're sad. Sad when we don't have x and y-intercepts, you guys. We also don't have a y-intercept, so we're sad. Okay, now the maximum or minimum point comes from the start point. So this point right here is going to help us with the maximum or minimum point. Okay, which in this case, is this the absolute highest or lowest point on your graph? Holy hot dog, you guys are brilliant. It is the absolute highest point, which means it's the maximum. Okay, which I forgot to label it on the other graph, so if you want to label it, you could. Like this one was a minimum, and in example 6, it was a maximum. Because there's a lot going on in example 6. Alright, so there you go. If you like to label things on your graph, I forgot. Again, the demon cats seem to be getting me a lot lately, so I forgot to label them. So if you like to label it, you can go ahead and label it on example 6 and 7 as well. Okay, so this is a maximum point, so the maximum point is at the point 1.33 or 4/3. I'm going to put 4/3 because fractions are our friends, and I love fractions. So it's going to be 4/3 and -2. Okay, and this one doesn't have a minimum, a triple none. Triple sad faces. This is like the most depressing problem. They're all like crying, and they're all crying into the same tear puddle. It's very depressing, you guys. Alright, now the end behavior. Again, this is when you ask yourself what is the graph approaching as we head to the left and right. So what y value is the graph approaching on the left and right? Guys, so this time I won't mess up my lefts and rights. Good golly. So this is my left side. So as we head to the left, what y value is the graph headed toward? Well, it's headed toward the y value in our start point, which is -2. So as x approaches -infinity, the y value approaches -2. And then on the right side of the graph, okay, so as we head to the right, the y values keep heading downward, so to -infinity, which is where the demon cats live, so watch yourself, you guys. Alright, so we're headed down for forever, which is a negative direction. So we're headed to -infinity, which I don't have a lot of space, so I'm going to try to squeeze in my answer right there. So that is -infinity. So this means we're headed down. Alright? Alright, and then the last thing we need to find is the interval of increase or decrease. Okay, now I already know it's going to be x is greater than something because all of our functions are headed to the right. I just simply need to know, is it an increase or decrease? So when I trace from left to right, we are headed downward, which means the graph is decreasing. Okay, so this one doesn't have an interval of increase, which is sad. So many sad faces, good golly. Alright, so none, and then the interval of decrease would be where x is greater than the x in our start point, which is 1.33 or 4/3, the way I like to write it, because fractions are our friends. Okay, so that says x is greater than 4/3. I know it's hard to see, which again, if you want to check yourself, on Desmos, if you type x is greater than 4/3, if you see it shades over the entire graph. So that means you did it right. Okay, if you ever check it and it's not shading over the entire graph when you have a square root function, that means you have the wrong interval of increase or decrease. So just be careful. But again, on these problems, it's always going to be x is greater than. Only with square root functions. Okay, this is not the case with quadratics, so be careful. All right, you guys. Well, that's about it for this problem. I hope you guys had a swell time like I did. It was wonderful. The final step, of course, is to name our graphs because all graphs deserve a name. So, I don't know. Looking at this graph, I think it looks like a Doug. This is a Doug graph. Well, there you go, you guys. That's it for now. Toodaloo.